As we were talking about in class, we know that the exponential form is y is equal to b to the x. And the inverse of that would be the logarithm base b of y is equal to x. And there's a couple ways you can do it, but it all works out when you go back and forth. But let's do some examples. We did this one in class, but if 3 is equal to the log base 2 of 8, you write that exponentially as 2 to the third is equal 8. If we had 2 is equal to the log base 10 of x plus 5, we can rewrite that in saying 10 squared is equal to x plus 5. Log base e of x is equal to 4, or x is equal e to the fourth. And we do know we can call this, or log to the ln, but we'll work on that. Or you could say log base b of b to the third is equal to 3, so b to the third is equal to b to the third. And you can change from exponential to logarithmic. So, for example, 3 squared we know is 9, or log base 3 of 9 is equal to 2. 5 to the third is equal to x, or log base 5 of x is equal to 3. A to the b is equal to c, so log base a of c is equal to b. A couple of these that are nice to remember is log base b of b is equal to 1. The log base b of 1 is 0. The log base b of b to the x is equal to x. And b of log to the log base b of x is equal to x. I think these particular ones right here are self-explanatory in the fact of b to the 1 will always equal to b, so that makes sense. And if b to the 0 will always equal 1, so those make sense. I think the other two are a little less explanatory, because if you have base b to the, really if you think about b to the x would equal b to the x. In other words, these kind of cancel out. And if you think about this, you have b to the log base b of x. And if you think about how you want to write that out, if we did the logarithms to both sides, meaning we know that log base b, this b, is equal to this x, it also equals the exponent, which is log base b of equal to x. And that's why those work out. But it's just a little less optional. So as we do this, we also can actually start applying certain things. So there's some things we don't need a calculator for, but you certainly can use them. But let's think about this. If we have a log base 8 is equal to 1, then, or I'm sorry, if we have log base 8 to 1, the answer would be 0, because 8 to the 0 will give you 1. If we had log base 5, we know the answer would be 1. Log base 2 to the fourth, that would be 4. And 3 to the log base 3 is 7, well that's equal to 7. So what about log 3, 1? That would also equal 0. What about log base 27, 27? That would be 1. How about log base 3 of 3 to the negative 1/3? That would be negative 1/3. And if we had 4, log base 4 of 232, that would equal 232. So how do we graph logarithms? Most people find it easier to change the x and y and graph the exponential and then flip it. But we'll do some graphs of that. But So example would be log 3 of x. Again, you can do an XY chart, but in this case, think about it as it'd be far easier to find the y's to plug in to get the x, because if we know, let's do -2, -1, 0, 1, 2, 3, if that's the case, then if you think about it, really, if you rewrote it, it's 3 to the y is equal to x, correct? So 3 to the -2 is 1/9. 3 to -1 is 1/3. 3 to 0 is 1. 3 to the 1 is 3. 3 squared is 9. 3 cubed is 27. So when you go to graph that, we know that 1, 0, 3, 1, 1, 2, 3, 9, 2, 4, 5, 6, 7, 8, 9, 1, 2. Then we know it's going to get closer and closer, but it's really not going to cross the y-axis at all, right? Because it'll get closer and closer, but it won't get to 0 because -2, -3, x will get closer and closer to 0 without touching. So we're looking at something like that. And if you think about it, which I know you try hard not to, but if we drew an x equals y, which is helpful, and we drew the inverse, it would look like this, and if you put them on top of each other, they would mirror each other. Let me do another one for you. Let's think about a decay, right? So if we did y is equal to 2, if y is equal to log 2/3 x. And again, I can make an XY chart, and it'll be easier to write the exponential. So if we did -1, 0, 1, 2, 3, you would have 3/2, 1, 2/3, 4/9, 8/27, getting closer and closer. So if we graph that, right, 0 or 1, 0, so that doesn't change. If we did -1, it'd be 1.5. Oh, it would be great if I actually graphed -1.5. So 1.5 would be -1, and getting closer and closer in would get us further up y, so we're looking at something like that. Alright, so for class today, I want you guys to graph some logarithms.